Hi, welcome back to the Transformations Test Review for Unit 8. We've already done page 1. Let's move on to page 2. Our triangle below is dilated by a factor of 1/3, about the point 40, and translated 7 units to the right. What is the location of S after the composition of transformations? So notice I'm only worried about the location of point S, which is kind of nice because when we're dilating about a factor around a point that is not the origin, there's kind of a process we have to go through. So let's review what that process is. Okay, the first thing I have to do is look and see where is that point S. So point S is at -5, 3. Okay, then I need to know what is the change from the center of dilation to that point. So my center of dilation is at 4, 0. 1, 2, 3, 4, 0. This is my center. Okay? All right, so if that's my center, S is going to be, to get from the center to S, I'm going to have to go back 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. So my X value is changing by a -9, because moving to the left. And then my center, I'm moving up 3. Okay, then the next thing we did once we figured out that change is we multiplied by the scale factor. My scale factor is 1/3, so times 1/3 times 1/3. 1/3 of -9 is -3, and 1/3 of 3 is +1. So this tells me my new change from my center. So I can see I'm going to go left 3 and up 1. So I'm going to go left 3 and up 1. That's going to be my S prime. Okay? And if you want to find those coordinates, if you didn't have a graph, we would take this point right here and we would add it to my center of dilation. So I've got a +4 that I'm adding, and I've got a 0 that I'm adding. And so I know that my S prime is going to be -3 plus 4 is 1. 1 plus 0 is 1. S prime is the point 1, 1. Okay? So then it says, then I'm going to translate 7 units to the right. So then I'm going to take this and I'm going to move it 7 units to the right. Or, remember, if you're doing X plus 7 to move to the right, and we're not going up or down at all, so my Y value doesn't have to change, right? My S double prime, when I add 7 to my X value, that's going to become 8. My Y value isn't going to change, it's going to stay 1. If I move S prime 7 units to the right, 1, 2, 3, 4, 5, 6, 7, it's going to end up right here at 8, 1, S double prime. So the location of S after the composition of transformations is the point 8, 1. This is my image of point S. Okay? All right, let's look at number 5. In the diagram below, the perimeter of triangle DEF is 36 centimeters. Determine the perimeter of triangle ABC. All right, and then I have my center of dilation. Remember we said it's real important to make sure you're comparing always whenever you're using these distances from the center, you're always using the whole distances. We never compare part of a piece. We're never going to actually use this 18 here in our proportion. Okay? Perimeter matches with individual side lengths. Okay? So we just need to make sure that we stay consistent. Okay, so whenever I start to set up a proportion, I have 2 triangles, DEF, and I have triangle ABC. You need to pick one that's always going to go on the top of your fraction. I'm going to go ahead and say that I'm going to put ABC always in the top of my fraction. And I'm always going to put triangle DEF in the bottom of my fraction. And as long as you stay consistent, you're okay. Okay? So, if I want the perimeter of ABC, and I know the perimeter of DEF is 36, 36 is going to go in the bottom because it's DEF. And my X, the perimeter I'm trying to find, is going to go in the top. Okay? So then, I need to look at some other numbers. I don't have any other numbers on ABC except what I'm trying to find. So I need numbers that I can use. They didn't give me any, but if I look at the distance from the center of dilation to A, I can figure out how long that piece is, right? So to get from the center of dilation to A, if I do 30 minus 18, that's going to give me that value. So 30 minus 18 is 12. Okay, so from the center of dilation to triangle ABC, that distance to point A is 12. And since it's from triangle ABC, I'm going to move it on the top 12. Okay, now sometimes it's real tempting to go, okay, well then to get to D, that's 18. But remember, we always have to go from our center of dilation. So we're really going from the center all the way to our triangle DEF, and that value is going to be 30. DEF goes underneath, so my 30 goes here. Okay, now all I have to do is cross multiply here and here. X times 30 is going to be 30x equals 36 times 12 is 432. Divide both sides by 30. And x is going to be a value of 432 divided by 30 is 14.4. So my perimeter of triangle ABC is equal to 14.4, and my units everywhere have been centimeters. Okay. All right, let's look at number 6. Point P under the translation x plus 6, y minus p becomes p prime. Describe the transformation that is taking place and determine the point on the graph that will have the same coordinates as P. So what they mean by describing the transformation is, what does this translation mean? What's happening here? What does this plus 6 mean? What does this y, or what does this minus 10 mean, right? So I know when I add to x, I know I'm going to be increasing when I add to x. So that's going to move me, when I get bigger numbers of x, I'm going to move to the right. So I'm going to move 6 units right. And then negative 10 on the y, when I take away from y, I know I'm going to move down. So 6 units right and 10 units down. That's what they mean by describe the transformation that is taking place. Determine the point on the graph that will have the same coordinates as P prime. Okay, so I'm going to do exactly what this tells me to do. I'm going to move 6 units right, 10 units down, and see which one of these points I land on. So 1, remember you don't count when you first put your pen down. So I don't start counting here 1, that's 0, I haven't moved yet. So I've moved 0 units. I don't say 1 until I've moved here. So this is 1, 2, 3, 4, 5, 6 to the right, and then 10 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can see that N will have the same coordinates as P prime. Okay, let's look at number 7. Number 7, triangle XYZ is reflected across the line y equals negative x. What will be the coordinates of x prime, y prime, z prime? All right, so what I need to do on this one is I need to figure out what my rule is for y equals negative x. So the first thing I'm going to do is I'm going to figure out what my points are. X is at 0, 4, 5, 6, 0, 6. Y is at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 5, 6. And Z is at 1, 2, 3, 4, 5, 0. Then I'm going to look at my formula chart and see what does it tell me to do when I'm reflecting across y equals negative x. So it's a reflection in y equals negative x. It's this very bottom one. It says take your xy point and reflect it to the opposite of y, the opposite of x. So xy is going to become the opposite of y, the opposite of x. Okay? All right, so let's do that. To get x prime, the opposite of y. Y is 6, the opposite of 6 is negative 6. The opposite of x is 0. There is no such thing as the opposite of 0, so it just stays 0. Y prime, the opposite of y is going to be negative 6. The opposite of x is going to be negative 5. And then z prime. The opposite of y is 0, so that stays 0. The opposite of x is going to be negative 5. So here are my coordinates for x prime, y prime, z prime. And when I graph that, I should expect it to reflect across y equals negative x, which is my parent function that has been multiplied by a negative 1. So instead of having an uphill slope of 1, it's going to have a downhill slope of 1. Okay? X prime is at negative 6, 0. X prime. Y prime is at negative 6, negative 5. And z prime is at 0, negative 5. And we can hopefully see that if we were to fold our paper in half along this diagonal line, these points z and z prime, x and x prime, y and y prime would land right on top of each other. Okay? In the next video, we will look at page 3 of the Unit 8 review. So come on back. See you then.